All right, so today we're going to put everything all together. We're going to do all the stuff by hand. We're going to sketch the graph. We're going to use the calculator to finish sketching the graph. And then we're going to use the calculator to find the range, the increasing and decreasing intervals, and the maximums and minimums. So the first function that we are going to look at today is 2x squared plus 6x over x to the third plus 5x squared plus 6x. And so first I'm going to go ahead and look for the y-intercept. I need to have numbers in the numerator and denominator that do not have an x attached to them. And so that would be 0 divided by 0, which is undefined. So for y-intercept I'm going to put none. For my horizontal asymptote, I'm going to look for the degree of the numerator and the denominator. The degree of the numerator is smaller, and so that means that I have a horizontal asymptote at 0. Now I'm ready to go ahead and factor the problem. So for the numerator, I have a GCF of 2x. That leaves me with an x plus 3 left over. In the denominator, I have a GCF of x. And so I can go ahead and take that out. That leaves me with x squared plus 5x plus 6. And so I'm looking for two numbers that multiply to 6 but add to 5. The two numbers that would do that would be 3 and 2. So I have a GCF of x in the front, and then I have an x plus 2 and an x plus 3. All right, so in this problem, it's a little bit interesting because if you can recognize it, there are actually two sets of factors that cancel out. We have the x plus 3's. Hi, Carrington. Shout out to Carrington. You to go. We have a whole at -3. And we also have these x's. X cancels with x. And so that means that we also have a whole at 0. So there are two of them. So I'm going to go ahead and do the process that I normally do when I have a whole. I'm going to write down my leftovers. So I have 2 over x plus 2. And then I'm going to go ahead and take that x coordinate and plug it in to find the y coordinate of the whole. So 2 over -3 plus 2 is 2 divided by -1. And so that just equals -2. Then I have 2 divided by 0 plus 2, which is 2 divided by 2, and that just gives me 1. All right. When I look at the factors that are left over in the denominator, I see an x plus 2, and so that tells me that my vertical asymptote is x equals -2. When I look at the numerator, I can see that I have a coefficient that's left over, but there's no x attached to it. The x that was attached to it ended up being the whole, and so that means I do not have any x-intercepts. There's nothing left over on top to make an x-intercept. So now for my domain, I have all real numbers, but I'm going to skip 3 values. I'm going to skip 0, I'm going to skip -2, and I'm going to skip -3. No 0, no -2, no -3. Okay, so I'm going to go ahead and copy all those things down on my graph. So I have a horizontal asymptote at 0. I have a vertical asymptote at -2. There is a whole at 0, 1. And there is a whole at -3, -2. And then I'm going to go ahead and graph this on my calculator to be able to fill in the rest of the graph. I'm pretty sure that the curves are going to go right here and right here. They're going to follow the asymptotes and go through those holes. But I just want to make sure that I'm getting correct points for all of that stuff. So I have 2x squared plus 6x divided by x to the third plus 5x squared plus 6x. And you can leave your window at the normal window if you want. I'm going to go ahead and change it just so it matches the graphs for this unit. I used these grids, -8 to 8. So we'll go ahead and graph that. And then you can use the table, or you can just plug in numbers. I don't know why I don't like using the table, but I don't. So I'm going to go ahead and plug in some values there. I know what's happening at the whole, but maybe at like negative 2.5, I might want to know a value there. So at negative 2.5, we're at negative 4. Maybe at negative 4, I'll want to know. Sorry, you can't see that. Negative 4, I've got negative 1. Negative 5, I've got negative 2/3. Okay. Probably want to know something at negative 1. Negative 1 is 2. Negative 1.5 is 4. 2.5. And so that's a lot of points there. I can use that to fill in the graph. All right, so I want to be careful that when I write my domain and range that my notation matches. And so I'm going to go ahead and write my domain not in this notation. This is the set notation. I'm going to write it in the interval notation because that's how I'm about to write my range. So I'm going to say that the domain is from negative infinity, and the smallest of those three numbers is negative 3. So that's the number I'm going to skip first. So from negative infinity to negative 3, and then from negative 3 to negative 2, and then from negative 2 to 0, and then from 0 to infinity. So I'm just writing in that interval notation all the numbers but skip negative 3, skip negative 2, skip 0. And I made sure that I wrote my notation correctly. I went from the smallest number to the biggest number. All right, so for my range, I'm going to go ahead and look at this graph. So at the very bottom of the graph, I can see an arrow going down. So we're starting with negative infinity. And I have all these negative numbers. I have all these negative numbers. And then I get to negative 2, and there's a hole there. And so I do not have negative 2. And then I have negative 1.7, negative 1.5, negative 1, negative 0.5. I do not have 0. There's a horizontal asymptote there. So then I'm going to say from negative 2 to 0. Right? So I had negative infinity up to negative 2, and then I had from negative 2 to 0. So I'm done with the left curve. I've written all the range from the left curve. Now on the right curve, I have from 0, I have 0.5, I have from 0 to 1, and then I have to skip 1. And then from 1, I have all the values all the way up forever. So my range, negative infinity to negative 2, negative 2 to 0, 0 to 1, 1 to infinity. All right. For me to be able to find the increasing and decreasing intervals, I first have to know if I have any maximums or minimums on the graph. And in this particular graph, I do not have any maximums or minimums. So if you recall, maximums and minimums look like mountaintops and valleys, and that doesn't happen in this graph. It's kind of like you're going around the corner of a table. So like it just goes down, and this just goes down, but it's kind of like around another corner. So no mountaintops, no valleys. I'm going to say none and none. I'm going to make sure I always look for those. Even if there aren't any, I'm going to put in my I'm going to check it. I'm going to just write none. Now, if I can see visually that there aren't any of those. But if I look in my calculator and I say, maybe there's a minimum down here, I'm going to use my calculator to find it. Then I would do second trace, minimum, and I'm going to say, I don't know, that seems like a good left bound. I'll use that one. And I'm going to do, that looks like it. I might be past the minimum now, and I'm going to do that. Your calculator is always going to find an answer for a minimum. It doesn't care if there's a minimum or not. When you program your calculator, if you are saying calculator, look for a minimum somewhere between here and here, your calculator is just going to find the lowest point, and it's going to tell you that's the answer. So you have to be smart enough to know when to ask your calculator to find it for you and when to not ask your calculator. So in this case, since there is no mountaintop and no valley, I'm not going to ask my calculator for an answer because I know it will give me the wrong answer. So no maximums and minimums, and that means that I am ready to find the increasing and decreasing intervals. So here, I'm going to bring back the stick figure that I used in Math 3, because I think that I like that little guy and I've missed him. So here's a stick figure, and he is walking downhill, and so that means that he is decreasing right here. And then he falls in the hole and dies, and a new stick figure pops up. And this stick figure is walking down really fast, and he slides into some sort of abyss. I don't know what happens to him, but he dies as well. So we have two dead stick figures, but they've been decreasing. And then we have a new stick figure that pops up right here. So the stick figures go on the graph from left to right. Because we're in America, that's how we do things, from left to right. So stick figure, he's going down, he dies in the hole. This stick figure slides down, he dies on the slide. This stick figure is also going down, and he falls into this hole and dies. And then we have a new stick figure who pops up, and this stick figure walks down, but only slightly down. It's like when you're riding your bike and it's just a little bit easy. It's a downward slant, but just not very steep. And he just walks forever and ever and ever. That's it. So we're going to say for our increasing intervals that we have none. There was never a point where our stick figure went uphill. But we have multiple decreasing intervals. The stick figure is decreasing from an x value of negative infinity to an x value of negative 3. That's where he fell into the hole. I'll put the U there. Then the new stick figure started at an x value of negative 3, and he fell off to wherever that slide down went to, but that was an x value of negative 2. So he was decreasing from negative 3 to negative 2. It just took him a long time to do that decrease. And then we have the new stick figure up here. He starts decreasing at negative 2, and he decreases until the x value of 0. And then our last stick figure decreases from an x value of 0 all the way over here to an x value of positive infinity. All right, so that was the first problem. We're going to go ahead and do one more. So this problem is y equals 1 over negative 2x squared plus 6x. So again, we're going to start off with finding the y-intercept. I need a number in the denominator that does not have an x attached to it. So I have 1 divided by 0, which is undefined. So that's none. If I compare the degree in the top with the degree in the bottom, the degree in the top would actually have had an x to the 0. That's why it didn't even show up in the problem. So if I compare 0 with 2, then obviously the top is smaller. So I have a horizontal asymptote at 0. I'm ready to go ahead and factor this problem. So I'm going to factor out a GCF of negative 2x. And that means that left over I have an x minus 3. So I don't have any factors that cancel. That means there are no holes. I have 2 factors left over on the bottom. That means I have 2 vertical asymptotes. So I have a vertical asymptote at 0 and a vertical asymptote at positive 3. There are no factors on the top, so I do not have any x-intercepts. And for my domain, I can see that I have all real numbers, but I should skip 0 and skip 3. Okay, so I'm going to go ahead and draw the things that I have, which is not much. So I've got this horizontal asymptote. I have a vertical asymptote at 0 and 3. That's it. Okay, I'm going to go ahead and graph that. 1 divided by negative 2x squared plus 6x. Okay, that's kind of hard to see if you have a calculator that's as old as mine. So I'm going to go ahead just like I normally do. I want to know what's happening to the left of 0, so I'll plug in negative 0.5. At negative 0.5, we have negative 0.28. That's like right there. What about negative 0.25? Negative 0.25 is negative 0.6. This is just like really close to this asymptote. At negative 2, gosh, it gets really, the reason why you can barely see that is that this curve is just super close to this asymptote in the corner right here. Goodness gracious. Okay. So there's that. Okay. How about we do 0.5? At 0.5, I have 0.4. At 1, I have 0.25. At 2, I have 0.25. I wonder what happens between those. 1.5 is 0.2222222. 2.5, 0.4. And I know how asymptotes work, so I know that like this corner right here, I know that it's going to follow the asymptote this way and follow the asymptote down. On this one, this bottom piece is not necessarily following that horizontal asymptote. It doesn't have to. Horizontal asymptotes tell you what the ends of the graph are doing, the far left and the far right. And so for us, we are mostly concerned with the edges of this. So I'm not concerned with this part. I can see that's kind of swooping down like that. But I do know that edges are going to follow the asymptotes up here, like this. Okay. And then I'm interested to see what's happening at 3.5. 3.5 said negative 0.28. This graph is just real close to these asymptotes. All right, so for this one, I'm going to go ahead, just like last time, and I'm going to write my domain in that interval notation. So I know I'm skipping 0, and I know I'm skipping 3. So I'm going to have negative infinity to 0, and 0 to 3, and 3 to infinity. And then the range on this one is kind of interesting. So you can see that these two pieces of the curve are what we're going to look at first. So I see arrows down, so I have negative infinity up to the horizontal asymptote of 0, and I can see that happening on this side and this side. So I have negative infinity up to the horizontal asymptote. And then if you can see, this did not get that close to the asymptote. Like, I mean, it's close, but there's definitely a little gap of space there. So I need to find the minimum value down here so I know how close it got to 0. So I'm not sure yet what that number is. I'm going to put a bracket there, though, because that's an actual point on the graph. And I'm going to leave some space to write the decimals of whatever the y-coordinate is that is the very lowest right there. Because I know there's a little gap here. There's some decimals for y that are slightly bigger than 0 that are definitely not going to be included. So I'm going to leave some space for that. But I can see that all the other values are included all the way up to infinity. So what I need to do next is I definitely need to find that minimum. So I'm going to look at my calculator. And I'm going to find the minimum. Okay, so if you guys can see, there's a little space on the corner where it curves up. I'm using that as my left bound. And then on my right bound, I'm going to look to the other side where I can see where it curves up a little bit. I'm going to use that as my right bound. I always ignore the guess. And there's my minimum right there. And the minimum 1.5, when your calculator does that 0, 0, 0, 0, 0, 0, 0, it's just having a hard time saying 1.5. So I'm going to go ahead and say that my minimum is 1.5, and then I have as the y-coordinate 0.222222222, which I believe is 2/9, but I'm going to go ahead and write it like this. So that means that this value right here was actually 0.22222. And that we have a few y values that are not on this graph. 0.001 is not on this graph for y, 0.1 is not on this graph, 0.20 is not on this graph. We do have some missing y values. Okay. All right, so for max, I don't see any mountaintops, so I'm going to say none. And then I do need to find my increasing and decreasing, so I'm going to pull out those stick figures again. So I have the stick figure, he starts on the left, and he is going to walk down this way and then fall out and die. So he's decreasing there. And then a new stick figure pops up, and he's right here. And he is doing this very steep decrease. And then he hits that minimum, and then he increases. And then he shoots off into the sky and dies. He actually flew into a bird and hit the bird and killed himself on accident. So then we have a new stick figure right here. And this stick figure is walking up and over this, so that's increasing. And he walks this way forever. The class next door is going nuts. Can you guys hear them? Probably. All right, so our increasing interval is from this minimum value, and if you guys remember, we always use the x values. So that minimum value was 1.5. So we are increasing from 1.5 to the x value of 3, where that asymptote was. And then we are increasing from 3 to infinity. We are decreasing from negative infinity, an x value of negative infinity, to an x value of 0. And then from an x value of 0 down to this minimum. So that's 1.5.